as we've been doing these surveys, we've been working on methodological ways to do them better. And they include things like estimating how many animals are missed on a typical line transect surveys. It's not like you're walking through a field and counting sheep. You can't actually be sure that every animal that's on your transect line is seen, because some of the animals especially spend really long periods of time underwater. And so we have to be able to estimate those correction factors in order to get accurate population abundance estimates. And it's been a stepwise progression. We're getting asymptotically closer, it seems, every year to estimating true abundance and correcting the various biases that are involved. And one of the tools that I'm most excited about is combining visual surveys, which is the tried and true gold standard for doing these sorts of abundance estimates, with acoustic methods. And so now we tow hydrophone arrays behind our ships. We're detecting a lot of animals that are submerged. This is especially important for things like sperm whales and beaked whales, which dive for periods of 30 minutes to, in some cases, up to 90 minutes, and where the fraction missed might be greater than the fraction that are available to be seen. In order to get abundance, what we typically do on our surveys is first to estimate the density of animals, the number of animals per square kilometer. And there's a method for doing that that's called line transect. It's a modification of an earlier method that was called strip transect, and it's kind of easier to understand the strip transect. So in strip transect, you go down a transect line and you count all the animals within a strip, say that's 1 mile on each side of your transect line, and then the density is equal to the total number of animals that you see divided by the area that you surveyed. And the area that you surveyed is the length of your transect times that 2 mile total width, mile on each side. It only becomes slightly more complicated when you miss some of the animals. So line transect is an alternative method where, instead of assuming you see everything within a strip, it only assumes that you see everything that's right on the transect line. And so if that assumption is true, then you can estimate what your probability of seeing things at different distances from the transect line based on the empirical data. So you actually measure the distance of everything you see, and the fall-off function there is your probability of seeing it at different distances from the transect line. And so from that you can just estimate an effective area searched. And from this effective area search you estimate density, and then if you want to get to abundance within a study area, then you multiply that density times the size of your whole study area.